Okay, there are a few things that I would like to reiterate before you take your quiz on 2.1 through 2.3. I'm going to put up all of the notes filled out that we went over in class, so you can look at those again. But I want to take a look specifically at 2.3 because I want to make some clarifications. Okay, 2.3. Now, if you are in 4th hour, these may look a little bit different, so check your notes carefully. Okay, the first thing is I want to take a look at example number 1. Okay, I just want to clarify that when they ask you to find the remainder, okay, they just want the single number. If they were to ask you to divide, then they would want the polynomial, like for example number 2. This is the answer if they ask you to divide. Okay, now I know I didn't make a big deal out of the restrictions, but if they ask you for the restrictions on the domain, I would write them all the time when you give me an answer for dividing. You cannot divide by 0. So on this one, x cannot equal 2. On this one here, your restriction is x cannot equal -1. So if they're asking you for any kind of restrictions, that's what they are asking you for. Okay. Now, I also want to clarify the factor form of the original polynomial. They may ask you to put it, and I keep saying they, I'm talking about WebAssign, okay? WebAssign may ask you to put it in factor form. So when you are dividing, let's go back up here to example number 1. When you are finding whether -2 is a solution, you are trying to figure out if x plus 2 is a factor. Does x plus 2 go into this evenly? And the answer is no, it doesn't, because you have a remainder of 13. Therefore, that's a symbol for therefore, -2 is not a solution. Okay, well, if -2 is not a solution, does not give you a remainder or a y value of 0 here, your p of -2, your p of -2, that means plugging -2 into the polynomial, does not equal 0. Therefore, x plus 2 is not a factor. Okay? Now let's talk about putting things in factor form. This is asking you to divide, but division is a way of helping you factor. If you get a remainder of 0, then it goes into this polynomial, goes into this polynomial evenly, but you can still write factor form even if you have a remainder. And this is what it would look like. So this divided into this gives you this polynomial. What is the factor form of this given polynomial here? That might be a question. Well, you take your divisor with your answer, okay, plus the remainder. This is the factor form of that. So if you see something like dx times qx plus rx, that just means factor form. So over here, x plus 1 doesn't go into this evenly, but it does go into it, and you get this with remainder of -12. So this is the factor form of that. Okay? Now again, what about the factored form of this? We talked about this. The factored form of this, if you're going to use 2x minus 3 as your factor, what's left over has to be divided by 2. So this right here is the factored form. Now it goes in evenly, right? So that means 2x minus 3 is a factor times this, with no remainder. This purple will give you the original problem. Now, if they say divide, they just divide, it's going to be this answer, and the restrictions for this answer is x cannot equal what you're dividing by. Whatever makes that equal to 0. So x cannot equal 3/2. Okay, so different questions. Divide means what do you get? So if I say, what is 100 divided by 5? Your answer would be 20. So if I say divide 100 by 5, you would give me an answer of 20. If I said, what is the remainder of 100 divided by 5? The answer would be 0. If I says, what is the factored form of 100 if 5 is one of your factors? The answer would be 5 times 20. So each question has a different type of answer. Okay, so going back to here, this is the answer to your division problem. This is the answer if they ask you for what is the factored form. And this is the answer if they ask you for the, This is the factored form. And this is the answer if they ask you for the remainder. Okay, so I just want to clarify that. Okay, I will put up the answers to these problems so you can check those. I'll put those up on the website as well. And then the last thing that came up and that I went over was the standard form of a quadratic. Your textbook refers to the standard form of a quadratic as what we call vertex form. So the standard form of a polynomial is different than the standard form of a quadratic. So I'm looking in the book. I want to find that. Here we go. So in WebAssign, when it says find the standard form of a quadratic function. The standard form of a quadratic function is the vertex form. I know that could be confusing, so just so you know, if they ask you for the standard form of a polynomial, that would be ax squared plus, and it's a quadratic, that would be ax squared plus bx plus c. So please do not let that confuse you. Okay. All right, I think that is everything. I will post everything for you to double check. Open notes, multiple attempts. There will be support for you on Friday's quiz. So I will see you then.